and then I can share your carry marks also, hopefully before Hari Raya, Cuti Hari Raya, because I'm going back to Kedah. Okay, so I need to finish everything. All right, so anything else? Okay, anyone yang nak tanya? So we are going to have, yeah.
Sorry to interrupt you, Doctor.
Yeah.
Regarding the next replacement class on Sunday, right?
Yeah. Mhm.
The thing is, me, Atika, and I know we kind of
Who's talking actually?
make a promise. Esther.
Oh, Esther, okay. Right.
Yeah.
Tiba-tiba dengar suara
Because
je Esther.
sorry, before you mentioned about the replacement class, the class, right? Before the week, Dr. Umi has asked me, Atika, and I know to help her with the symposium program. It's on Sunday as well, the same day with the replacement class.
Siapa? Okay, sorry, I don't get it.
Dr. Umi, Dr. Makato
Uh-huh.
has asked us to help her in the symposium program that held
Okay,
on
can you just
Sunday.
ask from her, permission for 2 hours maybe? Only for our class? Okay, because okay.
But I
And
need
then you can
to
join her
confirm with
back.
her. Yeah, but I need to confirm with her because me, Atika, and I know will be helping the lecturers to take the marks for everything. So since starting from 8:30 to 5. So we
Yeah,
have to
that's the
confirm with
reason. Okay, so otherwise I will talk to Dr. Umi, okay, to excuse you all. All right? Only
maybe I'll
for
try.
that 2 hours.
Yeah, maybe I'll try talk to her tomorrow because tomorrow we have class with her.
Okay, all right. Okay, because you're going to have the last quiz on Sunday, next Sunday.
Yeah.
Okay, so and then all right, so I don't want to waste more time, all right? So because the time is very, very valuable, right? So let's continue with our lecture. So we are going to talk on simple linear regression. So we'll continue our previous topic, right? Okay, anything, Esther, please let me know. Okay, please get back to me.
Yeah, I'll get back to you tomorrow.
Okay, right. Right, so we already learned. Remember, I told you that for undergraduate and also postgraduate students, the analysis actually can be divided into 3 parts. Okay, so the first part is descriptive, and then the second part will be compare means, and the last one is to find relationship, right? Those are the 3 things, no matter whether you are undergraduate or postgraduate students, right? So for your FYP, you need to choose, right? You need to choose either one or some of, it depends, okay? So for postgraduate students, some of them need to use all of them. For undergraduate student, for the descriptive is compulsory. Everybody needs to do it, right? But you need to choose either compare means or to find relationship, either one, right? And then, so what we are going to learn today is actually the extension of correlation. You already know how to find correlation based on the scatter plot and also the correlation coefficient. Okay, those are the 2 things that you need to look at. But today we are going to learn more about correlation. In real life, okay, just to find the relationship, the correlation is not enough. So we need to do something else, which is more important, what we call it as prediction, right? Prediction. So we need to predict something in order to be more prepared with our life, our business, and so on, right? So therefore, linear regression is the tool that we can use in order to do prediction, okay? So the Pearson correlation measures the degree to which a set of data points form a straight line relationship, right? Before this, okay, we only draw the scatter plot, but we didn't even, draw a straight line. So this straight line is actually called, right? This straight line is also known as a regression line, right? So what does it mean by regression? Okay, regression is a statistical procedure that determines the equation. Okay, so in our case today, that we need to find one thing, okay, we need to predict, right? So in order to predict or to do prediction, so we must have a model, right? So what does it mean by a model? A model is a mathematical equation. Okay, just sounds so gempak, but actually you have learned it since primary school. So you have seen this one a lot, right? And then what are the applications, okay, that you can do, with regression? Okay, so the first one, actually to describe the factors that influence variability, independent variable. Okay, people, you don't have to worry. This one is actually in your book. So it's on page, let me see, what page is it? Yeah, 141. Okay, so the most important that we use regression is actually to get what factors influence variability independent variable. Okay, so when we do example, then you will understand what does it mean. And the second one, as I mentioned before, is actually to predict. Okay, is actually then we need to estimate an equation or a model in order to predict the value of dependent variable for a given value of independent variable. So I really want you to pay attention, because whatever we are going to learn, okay, today and also tomorrow and also Thursday will be in the final exam, all right? So you need to understand the concept. And then also we need to compare, all right? Alternative theoretical explains, for example, so consumer use specific price point in comparing alternative. Okay, so what happens? So if they have this kind of value, what happen? If they have this kind of value, what's going to happen? All right. So and then the last one, the most important is to make decision. So after we get an equation, the mathematical model, so it's easy for us to do an estimation. So for example, in 5 years, in 10 years, what's going to happen in the future? So this is what we call it as estimated equation. What if? Okay. So what if I have more stock this month? Can I make better sales next month, for example? All right. Okay, and then steps. So this is the step. These are all the steps that you need to take before you can start with your regression analysis. All right. So you need to decide. The first thing you need to decide who is going to be your X and who's going to be your Y and who's going to be your X. Right. So Y is your dependent. X will be your independent. So who's going to be depend on who, right? So that one is very, very important. And then as I mentioned earlier, we need to estimate the parameters. Okay, the parameters, what does it mean? I will explain later, okay, of the regression equation. And then we need to interpret estimated parameters and goodness of fit. What does it mean by goodness of fit? Whether the line that we draw for our data in on our graph, okay, so does it really good, okay, for the whole, to represent the whole data. And then lastly, to predict the value of y for the given value of x. Okay, so all this you need to understand in order to answer your final exam question. Okay, assumptions. Okay, as I tell you many, many times, what does assumption means in statistics? It means a requirement that you need to fulfill before you can use any statistical test, right? So one of the assumption, the error term, okay, what does it mean by the error term? Once we have the model, then you understand what does it mean by the error term, which is the epsilon, is a random variable with a mean or expected value of 0. Okay, so when we do estimation, when we want to draw a line, okay, for our data, we try to avoid making any error. So we need to assume that the error that we are going to make will be 0. Okay, so it means free of error, error free. Okay, that's what it means. The variance epsilon denoted by sigma square is the same for all values of x. Okay, so the variance we know sigma square. Okay, and then the values of error are independent. So it means that one point, okay, one data point won't influence the other data point. So they should be independent, right? So for example, this point, right? So they are all independent. So that's what it means, right? So the error term is usually normal, okay? So the data that you choose, okay, you select for your study should be normally distributed and randomly selected. Okay, so now today we are going to learn simple linear regression, right? Some okay, is also known as SLR, simple linear regression. So the word simple means it makes different, okay, from other type of regression. So for example, remember, before we start with this example, so you need to put in your mind, right, in your head, that the purpose of doing the regression is actually to make prediction. And to first, we need to find a mathematical model. So from the mathematical model, then we can do prediction. So let's look at the example of research question. Okay, so does knowledge about calcium predict, okay, calcium intake in sports science students, right? So you need to identify which one is your variable. So what do you think, guys? Okay, which one is actually the variable in this sentence? Does knowledge about calcium predict calcium intake in sports science students? Okay, which one is your variable? Can you tell me the first variable? Anyone? Suddenly my class is so quiet. Anyone?
Halo dokter,
Yes. Okay, who's that?
Satria dokter.
Okay, yeah, thank you, Satria. Okay, which one is the first variable?
Is it calcium intake dokter?
Okay, yeah, one of them is calcium intake. All right. What else? Okay, anything else? Remember, when we talk about correlation, we must have at least two variables. Okay. Thank you, Satria. Yeah, it's correct. How about the second one? Anyone?
The knowledge about calcium.
Yes, knowledge about calcium. Right? So we have 1 and 2. Sasa dekat bawah ni korang dah ada jawapan. Okay. Alright. So, and look at, okay, what do you need here? So we need, remember this one correlation that we are doing must be quantity versus quantity, right? If quali versus quali, we are not going to use correlation, but we need to use chi-square test, right? So here, quantity versus quantity. So therefore, this knowledge about calcium and calcium intake must be quantified. We must make sure that those variables must be in quantitative, right? So here it says that one continuous dependent variable. So, and then knowledge about calcium. So what we do, we make it as score. Score about 50, all right? So their knowledge, let's do a test. For example, a few questions, 50 questions. So we will depend on the score of the test, right? For example, and then the next one is continuous independent variable. Again, calcium intake. So how much, okay, how much the calcium has been taken, all right? So that one also here in milligram a day, right? So therefore, it is a quantitative variable, all right? So in order to decide which one is X, which one is Y, which one is dependent, and which one is independent, we need to use logic, right? So usually, we will see who actually depend on who. So in this case, calcium intake, how much they intake is depend on the knowledge about calcium, right? So then this one will be our Y, okay? And then this one will be our X. Okay, is everybody okay? Right, I know this one is not in your book, right? But because this is only an example. But on page 142, okay, you have like an empty space at the bottom, right? So you can write whatever we just discussed there, right? Okay, anything else? Okay, any question? Ada apa-apa? If not, let's move on. Now it comes for us to learn more about simple linear regression. Okay. In regression model, so we must have at least two variables, okay? Because we are dealing with correlation, relationship. So then in our case, those two variables will be called as independent and dependent variable, where independent variable will be denoted by, terbalik ni, by X, right? And the dependent variable is denoted by Y, right? The simple regression model, this is what we call it as model or equation, mathematical equation. As I told you before, you have seen this one a lot. Remember this one, y is equal to mx plus c. Ingat tak? Oh, kawan-kawan, do you still remember this one? Ramla, where are you, Ramla?
Yes, doctor, I still remember.
Still remember. Okay. So this Y is actually our dependent and X our independent, right? So what is M, people? Anyone? What is M?
Gradient.
Gradient or slope, right? Correct. And how about C? Hasif. C apa Hasif?
Y-axis intersection.
Yes, the y-axis punya intersection here, right? So that one is the C, right? So, but, okay, we are using the same concept, but now we're trying to, orang cakap, change a little bit, right? For the regression model. So we have the same one, Y, but the constant here, okay, the constant, we move it forward, right? And we still have this one, same one, actually mx, right? So this one is our C, and we have a term error here. Remember, we have error. Why? Because when we want to draw a line, okay, for a regression line, for all these dots, okay, so this is what we call it as a regression line. Okay, y is equal to mx plus c. So not all the dots actually on the line. Okay, so this is all the error that we make. Okay, we just estimate the line for all dots, right? So all this error, okay, we need to consider it as 0. Okay, it means that this line is perfect for everyone. So there will be no error, right? So that's the difference between, the equation that you have seen before with this one today, right? So B naught is the constant term of y-intercept. B1 is the slope, same as M, right? And E, the error term, and it must be random and normally distributed, right? Okay. So let's look at the B1, okay? So this one will be on page 143, right? So B naught, the value of B naught in a regression model, okay, provides the value of y-intercept, right? So that one is the constant. And so for B1, if, okay, x is equal to 0, the value of intercept is 1, okay? So when we have, for example, okay, this is 1, this one is x, all right? So for example, this one, so when x is 0, we have the value of y-intercept is 1, all right? Okay, for example. And then next one, B1. B1 is a gradient, as our friend said just now, or also slope. Okay, the value of B1 in a regression model give the change. Remember, the relationship, the correlation can be detected, can be identified when there is a slope. Okay, we already discussed that one before. Okay, so the value of B1 in a regression model give the change of y dependent variable due to the change of one unit of x. So for example, if x changes 1 unit, then B1, in our case, y is equal to 1 plus 2x, okay? So if x changes 1 unit, so it means that the y changes 2 units, 2 plus 1, right? So that's what it means by B1. Continue with what we have done before, right? So let's look at our book, okay? Okay, wait. Let me see the, okay. Okay. I think I would like to do the one in our book. Okay, page 146, right? Okay, people, please get ready. I give you 5 minutes to get your SPSS ready so we can do exercise number 1. Okay, are you ready, guys? Okay, once you're ready, let me know. Okay, thank you, Anong. Saya rasa orang yang kerap kasih respon dalam kelas saya ni macam Anong, Atika, Esther, who else saya rasa saya kena belanja you all minum lah. Kita tarik ke? Okay, after our semester nanti. Kerana being so very active in my class. Okay, so all right, so let's continue. We are doing, okay. Now we are trying to do question exercise 1 on page 146, right? So let's read the question. Use car company to investigate how the price of one of the local car models depreciates with age. Okay, the company management took a sample of 8 cars of the interested model and collected the following information on the ages in years and prices in hundreds ringgit. Okay, remember, so the number, even it just show the price 38, so it means that 100, so you need to add 2 zeros at the back, right? So 38, for example, it means 3,800, like that. Okay. Now we are given all this data on age and price, and then we need to construct a scatter diagram for this data. So we're going to answer one by one, right? So let's enter the data, right? So the variable view. So we have the first variable is age, right? Just put age, and then type is continuous, and then just let whatever apa given by the SPSS, right? 82, just leave it like that, and then just put label. So each now is in years, all right? Oh, capital letter pula. Please just do it in all small letters, right? So, and then make sure your measurement, put it as scale because it's quantitative. Right? Is everybody okay? So this one also need to change to small letters. And then the next one will be price, okay? And then just leave it here, numeric, and then just put label as price in hundreds. RM. Okay? Just put that way. And then again, put it as scale. Okay, I stop here for 2 minutes for those who are still typing. Okay, can follow whatever I have shown on the screen. Okay, Mawarda. Are you here, Mawarda?
Yes, Doctor.
Okay, saya nak you baca kuat-kuat data untuk age. Jadi kita sama-sama menaik data tersebut. Right, can you please read for us data for age?
8, 3, 6, 9, 2, 5, 6, 2.
All right, is that all? We have 8 data altogether. Is that correct? Okay, thank you for the lovely voice, Mawarda. Okay, so let's have, okay, for the prize. Okay, let's invite Zijin. Zijin, okay? Can you please read data for price?
First one is 38.
Oh, 38, sorry. Okay, next.
20. 95. 33. 267. 134. 112. And 245.
Okay. So is everybody okay? Did we miss anything? 267, 134, 112, and the last one 245. Okay, I hope everybody okay. Okay, good. Now it's time for us to do something that we call it as regression analysis. Very, very simple. All right. Okay, so the first thing, okay. Sekejap ya, benda ni telah menutup saya punya screen. So I can, okay, go to analyze. Before we use correlate, because we just want to find the correlation, right? But this time we want to do regression. Okay. And then you go to regression, linear, click that one. Okay. I stop here for 30 seconds. Okay, let's move. Right now, we need to put our dependent and independent variable information. So we already, before that, remember one of the first step, we need to decide who's going to be our Y, who's going to be our X. So in this case, who's going to be our dependent people? Is it age or price? Anyone? Anyone? Ada ke? Heran saya. Macam tak ada suara kelas ni.
Dependent is price.
Dependent is?
Price.
Okay. Dependent is price. And then you say, then age should be our independent, right? So why do we choose price as our independent and price as our dependent and age is our independent? Remember, people, we are talking about cars, right? So the price of the car, for sure, it depends on how old the car is, right? So that's the reason we choose price as our dependent and independent is our age, right? Not our age, but the car's age. Right. Then just click for the first one. I want you to click OK. Is everybody okay now? Okay, this is the first thing that you need to, apa orang kata, you need to keep, right, to answer our question. But our part A, we are asked to construct a scatter diagram. So how can we construct the scatter diagram? So we need to go, remember I show you before, go to graph, legacy dialog, legacy dialogs, and then go to scatter dot simple scatter, right? And then go to x-axis will be the price, age will be our x, right? And then it's up to you if you want to put the title here, then you can put here as price versus age, right? So for example, and then you can click continue. Okay. And click OK. So once you finish that one, you can click OK. So this is actually the scatter plot in order to answer your part A. So can you please copy this one down to your graph paper on page 146? Please do it now. Oh, jejak sis. Macam tak nampak sangat. Okay, that's the first one. Okay, people, what can you see on your screen? Is it my SPSS or my PowerPoint? Which one?
The one that we can see is the SPSS, but it's like covered with another
A few
tab, I think.
things.
Yeah.
Yeah. All right. So now you can see. Okay, is everybody done with your graph, your scatter plot graph? Have you done? Yeah. Okay. Thank you. Right. So now when we run our regression analysis just now. Okay. These are all the information, all the tables that we got from the analysis. Okay. So the first one we call it as variable entered or removed. So it means that here we use the method that we call it as enter. What does it mean by enter? We just enter all the variables, okay, all the data. So then the model summary, we'll talk about this one after this, okay? And then also ANOVA, okay, ANOVA. So it similar to the ANOVA that we have learned before. Okay, the table we have sum of square, degree of freedom, mean square, F, and also significant value, right? Same. And then we also have coefficient. So all these three tables, actually, the first one, the model summary, the ANOVA, and also coefficient means a lot. Okay, means a lot in order to answer our question part B, C, and also D. Yeah, B, C, D. All right. So let's answer the question. Okay. So I go to my PowerPoint. Where is it? My PowerPoint. Okay. So this is our part A. So we have this one is actually example. Okay. Example exercise 1. All right. So this is the part A where we have our graph, scatter plot, and then the next one, we need to find the value of R. Okay, so you can find this one is R here, R square here, right? So it's very easy. So for part B, okay, so our R is equal to 0.988, and part C, our R square is equal to 0.976. And then we need to give interpretation. What does it mean? Remember, for the R square, we call it as determinant equation. Is to determine whether it has a relationship or not, and we only answer yes or no, right? So from the value here is very high, okay, close to 1, then we can conclude that the variables, okay, the variables have correlation, okay? So yes, right? The variables have correlation or related, okay? And then the R here is to show the strength. And remember, we need to tell the form, the degree, direction first, okay, direction, and also degree, right? So in our case, this one, the form will be linear, and then the direction is positive, and very strong relationship. Then how you answer part B and also part C. Okay, is everybody okay? People, I don't want you just keep quiet. If you, please say something. Sarah, are you okay, Sarah?
Yes, doctor, I'm okay.
Okay, good. Okay, so let's move on to part D, right? So part D, we need to find the regression line or regression model, right? So part D, we need to find the regression line, okay, model online, right? So remember, the form should be y is equal to b naught plus b1x plus e, right? So we assume this e will be 0. Then how do we get the parameter? This one, what we call it as parameter, right? The value of b0 and b1. So the parameter you should get from this column right here, right? So then we have y is equal to constant is 317.696, okay? Minus, right? Minus, we just follow whatever given here, 34.087. Okay, so the E is 0, or you can just put it E here if you want to, right? So that's the answer for part D. Very easy and very simple. Okay. Ayo, what happened? Sekejap my mouse is not moving. Mak, kenapa mouse saya tidak bergerak? Okay, next one, give an interpretation. Sorry you all, mouse saya pula tak bergerak ni. Kenapa ya? Okay, just a minute. All right, so let me check what happened to my mouse, whether the battery is gone or what. There's something wrong. It's not the battery. Okay, hold on. I cannot even move anything here on my screen. Okay, let me change mouse. Saya tukar mouse pun tak okay. Alright. It's not touch screen. You cannot do anything. Okay, anybody yang boleh suggest what should I do? Kenapa ya mouse saya tidak bergerak? Anyone? Can someone help?
Doctor, you're using computer or laptop?
PC.
PC.
If laptop, I got no problem. I got choice.
Yeah.
50%. But this one is PC. So that's the reason I cannot close whatever I have open.
Restart the whole computer.
Actually, the computer was not okay just now. So the IT person just came down before class and helped me with this PC. So now dia buat perangai lagi. Because the problem is, my PC, I have a big screen. So I can see better. So otherwise, kalau saya guna ni, aduh, okay, never mind. So let's take a break first, okay? And then we continue in 5 minutes, right? Then we continue with part E, and then F, and also G, okay? Because you need to know how to answer the questions, because the format of the final exam will be similar to this question, or almost similar. Not exactly the same, I said only similar. Right, so let me check. Otherwise, I will change to my laptop.